Hey, algebra students. Today we're going to learn about negative exponents in the denominator of a fraction and also something that's called a quotient rule. So today's learning targets are to evaluate and simplify expressions containing zero and integer exponents in the denominator. Before we start, let's review what we learned about zero and negative exponents last time. First of all, I hope you all remember that negative powers or exponents are not the same thing as negative numbers. So what do negative exponents really mean? Well, let's figure this out using the x's. So x squared, if we expand it out, is the same as x times x. X to the first power is the same as a single x. And we know that to go from the first row to the second row, we need to divide by x. So if I divide by x again, we can figure out what x to the 0 power equals. What is x divided by x? It is equal to 1. So this is how we learned last time that any number to the 0 power is equal to 1. So let's continue following this pattern and get to the negative exponents. If I take 1 and divide x from that, it'll tell me what x to the negative 1 power is. So what is 1 divided by x? It is 1 over x. Let's keep going. Let's divide by x again and figure out what this one equals. What is 1 over x divided by x? Well, we know that when we divide a fraction by a number, it is the same thing as multiplying by the reciprocal of that second value. So 1 over x divided by x is really the same as 1 over x times 1 over x, which is 1 over x squared. And then one last time, if we divide by x, then we are going to end up getting 1 over x squared times another 1 over x, which means we get 1 over x cubed. So what we really need you to understand from this pattern is that when we have a negative exponent, we put it in the denominator of a fraction to turn it into a positive exponent. So that means negative exponents aren't negative values, but actually fractions. Now let's answer this question. So why is 0 to the 0 power undefined? Well, we know that when we have 0 to the first power and we expand that out, it would just be just a single 0. So to figure out what 0 to the 0 power is, I would need to divide by 0. But wait, is it possible to divide by 0 in math? No, it's actually impossible to divide by 0 like you guys all learned before. And that's why 0 to the 0 power is considered undefined. So let's move on to today's learning. First, we're going to take these two problems on the screen and expand it out in order to simplify. So I know 3 to the 5th power is the same as 3 times 3 times 3 times 3 times 3. So that's what belongs in the numerator. And in the denominator, I just have 3 times 3. To simplify this, we can look for what we can divide out of both the numerator and the denominator. I can do 3 divided by 3, which would turn into a 1. And here's another 3 divided by 3 we can do, which becomes a 1 again. So after we are done simplifying, we can get 3 to the 3rd power at the end because there's 3 times 3 times 3. Let's look at the bottom problem. This time we have 3 squared in the numerator and 3 to the 5th power, or 3 times 3 times 3 times 3 times 3 in the denominator. Like we did with the first problem, we can simplify because 3 divided by 3 equals 1, so that one goes away, and these two also go away, which leaves us with 3 to the 3rd power in the denominator of our fraction. And what did we learn above? We learned that When we have exponents in the denominator, that's actually the same thing as having a negative exponent. Do you guys notice anything interesting about the original problems and the simplified versions that we got? I hope you all notice that if you look at the exponents of what I boxed, you can see that the numerator, the exponent of the numerator minus the exponent of the denominator will give us the simplified exponent. So this is what's called a quotient rule. Whenever you divide two exponents with the same base, we can use this pattern and know that all you have to do is subtract the powers in order to simplify this without having to expand and cancel things out. So that means if we have something like 4 to the 8th power divided by 4 to the 6th power, instead of writing out 4 8s on the top and 6 4s on the bottom, whoops, I meant 8 4s on the top and 6 4s on the bottom, I can just take the powers and subtract them to get 4 squared, which is equal to 16, as my simplified exponent. So down here, this is our rule for the quotient rule. When dividing exponents with the same base, the base stays the same, but you subtract the exponents.